Assalamu alaikum students. I hope your people are doing amazing. Today we are going to start introduction to moles. As you people are aware that the mole is a unit to measure number of particles, and most of the people don't realize how we are going to perceive number of particles. So we are starting this class in order to understand each formula of the moles. So basically there are four formulas to find out moles, but we will start for the mass, then volume, then particles, and then with the concentration, and then we'll come to know how we are going to manipulate the formula as well as how we can interchange it according to the situation. So let's start and let's begin how the moles to understand. So according to Avogadro's, so capital N is for the numbers, small a is for the Avogadro's. According to a scientist, he says 6.02 exponent 23 particles are present in each mole. So we can say that 1 mole of any substance is equals to 6.02 exponent 23 particles. So what particles are? The question is this. Particles could be three things. The first thing is particles could be atoms, particles could be molecules, or particles could be formula unit. So you might be thinking, sir, why the particles are so different? So the question is, and the answer is likewise for the atoms. For example, if any element which is uncombined like carbon, like sulfur, like silicon, like argon, right? These are uncombined, so we can call it particles. So can I say 1 mole of carbon is equals to 6.02 exponent 23 particles? Should I call it particle or should I call it atoms? So we can call it atom. The reason is very simple, because we know that these are the uncombined element, so we can write atoms here. So for example, if I want to do it again for argon, let's say, so I can easily write that this is 1 mole of argon is equals to 6.02 exponent 23 atoms. So let's talk about the molecules. When we talk about the molecules, it could be like carbon dioxide, could be water, could be ammonia. So we can say 1 mole of ammonia is equals to 1 mole of ammonia, right, is equals to 6.02 exponent 23 molecules. And we can call it 1 mole of water could be equals to, you can see this is 1 mole of carbon dioxide is equal to 6.02 exponent 23 molecule. And when we talk about the formula unit, we call the ionic bonding, right, like sodium chloride, like magnesium oxide, likewise. So when we talk about this, we can call 1 mole of sodium chloride is equals to 6.02 exponent 23 formula unit. So whenever there is an ionic compound, we use, instead of the molecules, we call it formula unit. So this is how you understand. And the same thing goes for another thing, like I duplicate it and I make it for 1 mole of magnesium oxide, and these are the formula units. So this is a basic introduction how you are going to perceive for the atom, These are the atoms, these are the molecules, and these are the formula units. So let's begin with the formula. If we talk about the first formula, this formula is known as formula number 1, and this is basically for the masses. If they have given you the masses, then you can find it how this formula can be used. And one more thing which I forgot to tell you, and that is how you are going to symbolize. So the symbol of the mole is a small n, right? This is a symbol. This is a mole symbol. And the unit for the mole is MOL. This is the unit. I hope it's clear. Okay, moving on. The formula number 1 says number of mole is equals to mass upon molar mass. Mass upon molar mass is just like if there is a carbon, right? Or I can say if it could be AR, it could be MR. For example, if there is an atomic mass like carbon, or there is like silicon or like argon, we can take AR, relative atomic mass. And whenever there is carbon dioxide or sodium chloride, you can take molecular mass. Let me give you an example. For example, if the question comes, calculate number of moles of 5 grams of carbon. So what you people do, you just need to put the formula. You can see here. This is the formula. And what you need to do, you just need to put the values in it. And that is mass is equals to 5 grams divided by molar mass. The molar mass of the carbon is, you know that the carbon is 12. So we are taking this thing. This is called the AR. So the bigger number is known as the relative atomic mass. So you just need to divide 5 divided by 12 grams. Let me calculate it. And this is gonna be 5 divided by 12. It's 0.416. 0.416. So these are the number of moles present in 5 grams of carbon. MOL. I just need to change this question, and I'm just making it into carbon dioxide. Just have a look at it. Very simple. For example, if we do number of moles, and the question says calculate number of moles of 5 grams of carbon dioxide. So just need to copy paste the formula, and here we go. Yeah, mass upon molar mass, it's gonna be like 5 grams divided by carbon dioxide molar mass to be known. Carbon dioxide, carbon is 12 and oxygen is 16 multiplied by 2. 12 plus 32 and gonna be 44 grams. So 44 grams, the molar mass. I just need to divide it. 5 divided by 44 gonna be 0.113. 0.113 MOL, because MOL is the unit. I hope it's clear to you. Now moving on, and let's talk about the second formula. According to the second formula, formula number 2, according to the formula number 2, This is used for the volume of a gas. So before starting this, I would like to tell we have 3 boxes in which the gases are present. And here we go. I'm taking 3 gases. The first gas gonna be like argon gas or a hydrogen gas or a carbon dioxide gas. These are the 3 gases present in a container. And if we talk about how many number of moles are present, each of the container contain 1 mole, 1 mole and 1 mole. And when we talk about this is going to be 6.02 exponent 23, 6.02 exponent 23, 6.02 exponent 23. So these are the atoms and these are the molecules, and these are the molecules. So remember one thing, 1 mole of any gas occupies volume. 1 mole of any gas occupies volume that is 24 dm cube. 24 dm cube, right? So each of the container contains 24 dm cube. 24 dm cube. 24 dm cube. So the formula is, so can I say that the molar gas volume is equals to 24 dm cube. So remember one thing, 1 dm cube is equals to 1000 cm cube, and 24 dm cube should be equals to 24,000 cm cube. So sometimes they give you the value in cm cube, so you should remember the term 24,000 cm cube. Both are the equal. So let's start with the formula. According to the formula number 2, number of mole is equals to volume divided by molar gas volume. So let's begin with this. When we talk about the volume, so the question is calculate number of moles of 30 cm cube of carbon dioxide gas. So it's pretty simple. You just need to put the formula. The formula is number of mole is equals to volume divided by 24 cm cube, because 24 cm cube is the fixed value, right? Molar gas volume is 24 dm cube, and this is fixed and this is not changed. As I mentioned you, the value is given in cm cube, so rather than converting, I can also use this formula, volume divided by 24,000 cm cube. So it's gonna be like number of moles equals to volume divided by 24,000 cm cube. So the volume, it's gonna be 30 cm cube divided by 24,000 cm cube. So you can have a look. Cm cube and cm cube cancels. Cm cube and cm cube cancels. So 30 divided by 24, 0.00125. 0.00125 moles.